algebra students. Today we are learning about lesson 3.4, which has everything to do with arithmetic sequences. Arithmetic sequences are related to linear functions. That's why this is in our topic. First of all, I want to make sure that you have these definitions. A sequence is an ordered list of numbers that form a pattern. So what you're going to see is basically just a list of numbers, and we're going to look for that pattern in the sequence. And the term is each number in that sequence. So we'll see what that looks like here in example 1. Specifically, today we're going to be talking about arithmetic sequences, which means that each number in the sequence, so each term, is being found by adding that same number to get the next one. So it's formed by the same number being added to a previous term of the sequence. This thing that we're adding is what we call the common difference. So the common difference is that constant difference between the terms of an arithmetic sequence. And that is what you'll see is very similar to the slope of a linear function, because it's that thing that happens over and over and over again. We're going to talk specifically about the recursive formula today. And then next time we meet, we'll talk about the explicit formula. But the recursive formula is used to find the next term in the sequence. So I'll go over what that means as well. So we'll go ahead and just jump in and look at example 1 where we actually have a sequence. So example 1 is the sequence 26, 39, 52, 65, and 78. So what we're recognizing here is that each of these numbers is a term. So 26 is our first term. 39 is our second term. And so on. We're going to continue. Third term. Fourth term, fifth term, sixth term. And it goes on and on and on forever. That's what those dots mean. And we call way out here, where we don't actually see it, but this is the nth term. Basically, we can find any term number in this sequence by continuing to add this common difference over and over. So I could find the 100th term if I continued to add and add and add and add until I got to that 100th term. Now, when we look for this pattern, we're saying, what do I add each time to get to the next term? So if I go from 26 to 39, what I'm adding each time is that 13. And I'm going to look, and I also add 13 to get to 52. And then I add 13 to get to 65 and 78 and so on. So it continues. So what we say is that our common difference is 13. And we use the variable d for that. So d equals 13. Because they're talking about common difference here. Now, this is very similar to a linear function. One thing that you can recognize is that this is the slope. This is what repeats over and over again to get the next terms. We also can talk about the domain of this arithmetic sequence and how that's related to a linear function. So I'm going to go ahead and write that in here also. Now, the domain in a arithmetic sequence is a little bit different. That is the term numbers. So if I said, what is the first term? That's the input. If I plug in 1, my output is that number 26. So the domain is the term numbers. And this is restricted to the natural numbers, 1, 2, 3, 4, 5, 6, and so on. Okay, so again, my domain is 1, 2, 3, 4, and it continues on and on. So I'm going to put the dots in. My range is the output values. That's the actual numbers in the sequence. So for example, here, this can be anything. It could be rational numbers, it could be fractions, decimals, depending on what the sequence is. But in this case, it's the numbers 26, 39, 52, 65. And again, it continues on and on and on. So we can just leave it like that. Now, this is a discrete function because each of these is like a single ordered pair. We can't draw a line between them because it's only those specific dots. We're going to talk about the notation for this. So what's a little bit funky with arithmetic sequences is that instead of using like a sub n, like we use in function notation, so I'm going to write this in here. So if we look at a regular function, we're talking about like f of x or something like this. A sub n, or a of n, sorry, is the value at n. Right? So we would plug in n anywhere, solve it to see what our output is. So for example, if this was a function, we would say that a of 1 is equal to 26 because the first term is 26, and a of 2 is equal to 39 because the second term of this sequence is 39. But sequences use subscripts. Now, that just looks a little bit different in that instead of using the parentheses with this n, we use a and then this teeny tiny n down below, a sub n. So that means the nth term. If I say a sub n, I want to know what is the nth term. Basically, what is the value at n? If I use a sub 1, that's 26. So the first term is 26. A sub 2 is 39 because the second term is 39. And it goes on and on and on. The third term is 52. The fourth term, so a sub 4 is 65, and so on. So we just need to get used to using these subscripts for arithmetic sequences instead of function notation. So just one more notation to throw at you. Now, let's define the recursive formula. So I'm going to define it as a sub n equals a sub n minus 1 plus d. Sorry, and I'm going to scoot it over a little bit. And then you have to write what a sub 1 is. So when you write anything in the recursive formula, you have to tell me what is a sub 1. Okay, so a sub n is always the nth term. A sub n minus 1 is the previous term. So it's the term right before the nth term. We already know that D is the common difference. And then a sub 1 here is the first term. Okay, so if I say, let's use the recursive formula, okay, and we're going to find the next 3 terms of this particular sequence. So I know that a sub 1 here is the first term. So 3. 3 is my first term. My common difference is, what do I add over and over again? So I'm going to see, well, I'm adding 4 here. Well, I also add 4 here. So if I find the next 3 terms, I'm going to continue to add 4. And I get 15. 15 plus 4 is 19. And 19 plus 4 is 23. So there's the next 3 terms. Now, if I write this recursive formula for it, it's a sub n equals a sub n minus 1 plus 4, where a sub 1 equals 3. And that's all we know. They're not asking us to find any other term. They just want the recursive formula. Okay. Now, this last example is a story problem in which we're going to find the recursive formula for the height above the ground of the nth step of a pyramid. So what the problem is telling us is that each step is 26 centimeters tall. Okay, so if I create a sequence for this, the first term is going to be where I start. So how tall is the first step? Well, it's 26 centimeters. And then it says after that, each step is going to add another 26 centimeters. So I'm going to do that in my head. 26 plus 26 is 52. Plus 26 is 78. Plus 26 is 104. And it continues. So I'm going to draw the dots. So if I write the recursive formula, that's a sub n equals a sub n minus 1 plus my d, which is 26, where my a sub 1 is also 26. And that would be my answer. So today on your homework, you're going to have to write recursive formulas for particular story problems or for particular sequences. And then sometimes they're going to give you sequences that say, find the next 3 terms, and you have to figure out what that common difference is and add that multiple times. Good luck on your homework. Email me if you have any questions, and have a wonderful day.